All right, boys, we're back and ready for action. Part 2 of the super test taking up video. Okay, and technically in the test, we're only at question 2. Yay! Okay, so this one is saying write 3 different sets of fractions that have a sum, difference, product, or quotient of 2. That means your answer is going to equal 2 by an addition question, a subtraction question, a multiplication question, or a division question. So we were looking for you guys to be a little bit creative with this, okay? A lot of boys would do something like, well, 1 1/3 plus 2/3 equals 2. We'll accept it. That's okay. You weren't really challenging yourself or pushing your limit, but we'll accept it. So let's do a difference one. If I said, let's use this simple example and just reverse it. If I said I had 3 2/3 minus 1
2/3.
and 2/3. Mr. Moore and I did not prepare for this. We're just rolling. That's going to equal 2. Let's do it with a multiplication. So if I took the number 4 and I wrote it as a fraction 4/1 and I multiplied it times a half, I end up getting 4/2. 4 divided by 2 also equals 2. Now, if I wanted to use that same example and I took 4/1 and divided it by 2/1, this is a really simple example, right? This is the same as saying, well, I'm going to multiply it by 4/1 times 1/2, which gives me back to here, which equals 4/2, which equals 2. Remember, this is just the same as 4 divided by 2. Those are some simple examples. There are many ways that boys challenge themselves. If you want to see a challenge, ask Christian Craneman to see his, because he really thought outside the box with his. Okay, so these ones solving for x. We haven't done a lot of solving for x work so far this year, but really you're just trying to determine what that unknown number is, what that unknown variable. So if this one, if I know I'm adding fractions, I know I need to have a common denominator. So if I were to take this 1/2 and I wanted to make it eighths, I would multiply by 4. I would multiply this by 4. Then I'm left with 4/8 plus x/8 equals 7/8. Well, what are my options for what that x is, right? There's only one possibility. If I'm adding 4 plus something, it has to be 4 plus 3. So therefore, x equals 3. This one's a bit trickier. Upon looking at them, there isn't a lot of relationships that exist between 5/15 and 7 over an unknown. We're not sure what's going on here. But I know that if I simplify this, divide by 5 and divide by 5, I end up getting to 1/3. Interesting. I wonder if I can find a relationship with 7, where if I simplified it, I would get to 1/3. So 5/15 and 7 over something can be equivalent fractions because they could both simplify to 1/3. And if I put 21 here, and I divided this by 7, and I divided this by 7, I'm going to end up with 1/3. So 7/21, therefore x equals 21 is my way to get to 1/3. All right, into my word problems. Okay, Russell had $500 to spend. He spent 3/5 of his money. We've talked about this a lot. That's saying 3/5 of 500. It means multiply. I end up with 1,500 over 5. 1,500 divided by 5. Remember, the fraction line means divide, equals $300. So if he spent 3/5 of 500 on a PS4, it means he spent $300 on the PS4. Read this next part carefully. He spent 1/4 of the remainder on MLB The Show. Not 1/4 of 300, 1/4 of what he had left. So 500 minus 300 equals 200. He had $200 left. So now I'm saying 1/4 of, multiply, 200. So this is 200 over 4. 200 divided by 4 equals 50. So therefore, he spent $50 on MLB The Show. So if he spent $300 on the system and $50 on the game, he spent $350 in total. So now it's saying how much money did he have left? Well, $500 minus $350 equals $150. Therefore, he had or has $150 left. Okay, if it takes 3/4 of an hour to pick all the apples on one tree at Belanger Organics, there are 24 trees in total. How long will it take to pick all the apples? Well, again, let's estimate first here. Is it going to be greater than 24 hours? Think about that for a sec. It can't be, because one tree takes less than an hour to pick. So that means my answer has to be less than 24. It has to take less than 24 hours to pick all those trees. So this is saying 3/4 of an hour, and there's 24 trees. I'm really just taking 3/4 and I'm multiplying it by 24. So 3 over 4 times 24 over 1 equals 72 over 4. Again, this means divide by. 72 divided by 4 equals 18. Okay? Therefore, it takes 18 hours to pick the trees. Okay. Now, you could have shown this as a model as well. You could have said, you could have just added 3/4 a number of times until you got to 24, right? You could say 3/4 plus 3/4 plus 3/4. But again, that's what multiplication is, right? Multiplication is repeated addition. It's 3/4 added 24 times. So save yourself the trouble and go and multiply. Now, you could also have pre-simplified this. You could have divided this by 4. Divide by 4 and got to 1, and divided this by 4 and got to 6, and then you're at, up here, you're at 3 over 1 times 6 over 1. Okay, so if you didn't want to do this math here, you could have pre-simplified, and this is just 3 times 6 equals 18. All right, the last two. This one is an example of one we did in class. I'll just do one quick example here, but let's talk about what we want to accomplish. So A says, start at 100, make between 5 and 10 moves and make the biggest number that you can. We're not looking for a number here, gentlemen. We weren't looking for a specific answer. We weren't looking for the greatest answer. We were just looking that you understood how to make a big number. Now, how do you make a big number using these operations? If I started at 100, multiplying by 0.9 or multiplying by 0.5 or multiplying by where else were we? 0.99. Am I making big numbers or am I making small numbers? Remember, when you multiply by decimals or by fractions that are less than a whole, you're going to get a smaller number. If you divide by fractions or decimals that are less than a whole, you're going to get a larger number. So think about the route you would take. If you want to make a large number, you would want to divide by 0.6. You'd also probably want to divide by 0.09. And really, guys, what we were just looking for was, if you map out a little root here, like so, that's going to make you a pretty big number because you're multiplying by numbers greater than 1 and you're dividing by numbers less than 1. Okay, and all we were looking for is just you to write out the steps. So 100 minus 0.09, divide by 0.09. Okay, now this is an order of operations. You're not doing your division first with this because it's literally taking it a step at a time. So you went 100 minus 0.09 equals. So then you got to 99.91, and then you divided that by 0.09. Divide by 0.09, and right away you jump up, equals 110.11. Okay, so again, you're just showing the steps along the route as you go. Then you're multiplying that by 1.89. Whatever that product is, then you're subtracting 1.7. Whatever that difference is, then you're dividing by 0.87. You just have to show us the steps and end up at the finish with a number and show us that you knew that by dividing by less than 1, you got a big number. By multiplying by less than 1, you got a smaller number. By less than 1, you got a smaller number. All right, and then finally this one, again, another example of what we did in class. The outside edge of the rectangle represents the whole. Everything in here is parts of the whole, okay? So right away, if you want to start landmarking this, if you put a 1 here, you're saying that, okay, this is, if I look at the rectangle like this, I have quarters of that shape. So this one up here is half of a quarter. Half of 1/4 equals 1/8. Therefore, 1 equals 1/8. Okay? Then I went to this one, I said, well, look, that guy is half of this, so it's half of an eighth. So half of 1/8 equals 1/16. Therefore, 2 equals 1/16. I won't do them all, gentlemen, but again, that's how you showed your work. You're saying, well, I know that this is half of the quarter. You could even say that the whole shape can be divided into 4 quadrants, and this one was half of that one of those 4 quadrants. Therefore, it's half of a quarter. Therefore, it's an eighth. Okay, so there's a bunch of different options to doing this, and if you didn't have a chance to solve this problem, you can solve this problem now. Thank you, guys, and we'll see you tomorrow.